This is homework set 35 on the inverse function. Question 1 asks us to find the inverse of this one-to-one function. So I do this in a couple steps. The first step is to replace f of x with y, and that's just for convenience. All right, so I'm going to write this now like this. Y equals 4x plus 6. And I'll write it so it's actually readable. 4x plus 6. The next thing to do is interchange x and y. So that would give me x equals 4y plus 6. And then solve for y. If I solve for y, what am I going to do here? So I'm going to subtract that 6. I'll get x minus 6 equals 4y. And then what I can do is divide by that 4. So I'm going to get y equals, now I could get this. I could divide the whole side by 4, or I could divide each individual term by 4, getting x over 4 minus 6 over 4, but I'm going to write that like this. Y is equal to 1/4 x minus 3/2. And now, I'll do this up here, and now replace y with its new name, f to the negative 1 of x, right? F inverse. So I'll get this. F inverse of x is equal to 1/4 x minus 3/2. Question 2, for this function, one-to-one function, find the inverse. So I'll start here. I'm going to replace f of x with y just for convenience. So I'm going to write it like this. Y is equal to 1/5 x plus 6. The next step is to interchange x and y. So all I'm going to do here is just interchange the x and the y, and the equation will become x equals 1/5 y plus 6. Now solve for y. So to solve for y, I'm going to subtract 6. All right, so let's do that. Let's subtract 6. We'll get x minus 6 equals 1/5 y. And now what I'm going to do is I'm going to multiply by 5. So just multiply everything by 5. I'll get 5x minus 30 is equal to 1/5 times 5 is 1y. So how about if I write it y equals 5x minus 30. And now one more step. Let's replace that y. Replace y with f inverse. So I'm going to write f inverse of x is equal to 5x minus 30. So for this function here, y equals 4x minus 5. Let's find the inverse, and then we'll graph both of them. So I'm going to start here by writing the equation. Y equals 4x minus 5. Now, replace y, or interchange x and y. We already have y. So just interchange x and y. So I'll get x equals 4y minus 5. Now add 5, because I'm going to solve for y. I'll get x plus 5 equals 4y. Now divide by 4. I'll get 1/4 x plus 5/4. That's equal to y. Right, so here's the inverse. F inverse of x is equal to 1/4 x plus 5/4. Okay, now I've got that function and I've got that function. I'm going to graph them both. So first up, let's graph this one here, 4x minus 5. So this is a linear function. It's a line. It's going to cross the axis at negative 5. I'm going to come down here at negative 5, put a point. Now, the slope here, I'm up at the top right, the slope is 4. I can write that as a fraction, 4 over 1. And I want the slope as a fraction because what it tells me is how to make the vertical and horizontal changes. So I'll start at the 5. Now, the bottom number, you remember, is the horizontal change. Top number is the vertical change. So start back here at the 5. Go to the right one, up 4. Right one, up 4. Now, just to make it a little straighter, I'm going to do it again. To the right one, up 4. So to the right one, up 4. Might as well do it again. To the right 1, up 4. Still got room. Now connect those 4 dots, 4 points, with a line. Just pass a line through them. All right, so I just did that, and there is my graph of y equals 4x minus 5. Now, to get the graph of the inverse, I could just graph this one right here, or I could just remember that the inverses are symmetric around this 45-degree line. So if I look at this 45-degree line right here, that's the line y equals x, and then take this curve right here and rotate it around that line. So if I rotate that around the line like this, I'll get the graph of the inverse. Now, instead of just graphing this using that slope-intercept form, I'm going to do this. Notice that this point right here is 0, negative 5. That means that negative 5, 0 is on the inverse. This point right here is 1 and negative 1. Interchange the x and y. That means that negative 1 and 1, that's on the inverse. This point up here is 2 and 3. That means that, interchange them, 3 and 2 is on the inverse. And this one up at the top is 3, 7. That means that 7, 3 is on the inverse. Let's just plot those points. So negative 5 and 0. Negative 5 and 0 is right here. Negative 1 and 1. Negative 1 and 1 is here. 3 and 2. Over 3 up 2. That's here. And 7 and 3. 7 and 3, that's here. Now, as best you can, pass a line through those points. Now, can you see that if you were to take this red line, rotate it around that blue line, the 45 y equals x line, that you're going to get the green line? They're symmetric. Now look at this over here. 5/4. This crosses at 5/4. That's 1 1/4. All right, that's maybe 1 1/4. And then from here, I'm going to go over 4 and up 1. Sure enough, it looks like I'm back on the graph. So I think I've got it. So the green line is y equals 1/4 x plus 5/4, the inverse. In question 4, we're given this exponential function here, 1/3 to the x, and you can see it's a decreasing function, and we want to know which one of these graphs would be its inverse. I'm going to do this like this. I'm going to, first of all, let me make this one a little bit bigger here, just for a minute here. Look at some of the coordinates on this graph right here of 1/3 to the x. Passes through that point. Now that point is 0, 1. I'm going to note that. So here's what is on the function. On the function itself is 0, 1. That means that on the inverse would be, just switch them, 1, 0. Now, do you see, let's shorten that up a little bit here. Do you see a graph that goes through, 1, 0, 1, 0. It's not this one. That doesn't go through 1, 0. This one does. In fact, this is the only graph that goes through 1, 0. So I'm going to claim now that it's this graph right here. And does it look to you like if you were to draw this 45-degree line here and then rotated that graph around here, that this is the one you would get? Does that look like it? You really have to have a good imagination here. Question 5, the last one in this homework set, says this. This function right here, s of t equals 16t plus 249.4, where t is the time in years since 1990, what this function does, it models the billions of dollars of Social Security payments that have been made since 1990. So t equals 0, 1990. So here's part A. Use the model to estimate the Social Security payments to be paid in 2005. Now, 2005 is not here, so we're going to have to use the function. So we're going to have to use this function right here, s of t equals 16t plus 249.4 with t equals, all right, so how many years from 2005 are we? 2005 minus, everything starts here in 1990, so this is 10, 15 years. All right, so let's put in s of 15. This will be 16 times 15 plus 249.4. I got 489.4, and that's all in billions of dollars. So I'm going to put 489.4 here. But I guess we could round that off to 490 billion. Now, part B, let's get the inverse of this function. So here's our function. S of t is equal to 16t plus 249.4. All right, I'm going to replace s of t with y equals 16t plus 249.4. Now interchange the y and the t. We'll get t is equal to 16y plus 249.4. Now I'm going to solve for y. All right, so I'm going to subtract that. So I'll get t minus 249.4. That's equal to 16t. Let's divide. So I'll get 1/16 t minus 249.4 divided by 16. That's all equal to t. Now part B, let's get the inverse of this function. So here's our function. S of t is equal to 16t plus 249.4. Now I'm going to replace s of t with y just for convenience. Y is equal to 16t plus 249.4. Now interchange. So I'll interchange those. So I'll get t is equal to 16y plus 249.4. Now I'm going to solve for y. All right, so first up, why don't we subtract that 249? So I'll get t minus 249.4. That's equal to 16t. And now I'm going to divide by 16. Now I'm just going to write it like this. Oh, this is not a t. This is a y, right? That's a y. So I'm going to get t minus 249.4 all over 16. That's equal to y. And I'm going to replace this with s inverse of t is equal to t minus 249.4 all over 16. There's the inverse. Now, part C says, using the inverse function, which we just got right here, estimate the year when the payments will reach 507 billion. So I'm going to come over here and put 507 billion in here and try to find that time. So put that 507 billion in here. So S inverse of 507 turns out to be 507 minus 249.4 over 16. Now when I did that, I got approximately 16.125. I'm just going to say this is about 16. Now, that 16, this is years since 1990. So if I take 1990 and add 16, I am at about the year 2006. So that's what I'm going to claim here, 2006. And that closes out our questions on homework set 35.